Hey, this is our fourth review, and we're going to talk about polygons and also about special polygons, quadrilaterals. So the first thing to review is the names of the polygons. We name them based on their sides. So most of these you probably know by heart. Some of them you might need to remember, like a 7-sided polygon is called a heptagon, a 9-sided polygon is called a nonagon. Twelve-sided is dodecagon, and then all the other ones we would just call based on the number of sides they have. So a polygon with 36 sides we'll call a 36gon. So it's important to know these special ones in case their names are used specifically. We had some formulas that we used for polygons. A special vocabulary word here is the regular polygon, and that means that all the sides and all the angles are equal. So interior and exterior angles are equal. If we want to find one interior angle, I actually have these switched. So let me fix that. If I want to find the sum of the interior angles, I do 180 times n. N is the number of sides. N minus 2. And then if I want to find 1, I do that 180 times n minus 2, and I divide that by n, the number of sides. Remember, there's a trap here. A lot of people like to divide by 2. Don't do that. We're dividing by the number of sides, n. All the exterior angles add up to be 360 degrees. Remember, exterior angles are angles formed if I, say, extend this side. I have that angle right there. That's an exterior angle. There's one at each vertex. I'll remind you that a vertex is a point here. So this pentagon has 5 exterior angles. They all add up to 360. And if I want to know how big one of them is, and it's a regular polygon, I could just divide it by n, the number of sides. Another note here that an exterior angle and its interior angle form a linear pair, and that means they are supplementary. So this interior angle and this exterior angle add up to 180 degrees. So that might become helpful when we're doing some practice. So quadrilaterals are 4-sided polygons, and they're split into 2 groups. We have parallelograms. Those are polygons that have 2 pairs of opposite sides parallel and congruent. And we have trapezoids. That's a quadrilateral that has only 1 pair of sides that are parallel. So parallelograms can be rectangles, they can be a rhombus, and then if a rectangle and a rhombus are put together, we create a square. And we have a special type of trapezoid called an isosceles trapezoid, and that's when the 2 sides that are not parallel are equal to each other. So I think this is probably the most important page, sort of a quick summary of all of the properties of the quadrilaterals that we talked about this year. So I've listed them by sides, angles, and diagonals. Parallelograms have opposite sides that are congruent and parallel. So remember that this symbol means congruent or equal, and the 2 lines right here mean parallel. The opposite angles are congruent, and then the angles that are consecutive are supplementary. They add to 180, and the diagonals bisect each other. All these same properties exist in rectangles, in rhombi, and in squares, with some more specific properties. So the angles in a rectangle are all 90 degrees, and the diagonals are also congruent. These diagonals bisect each other, and they're congruent. In a rhombus, the sides are all the same, they're all congruent. Nothing special about the angles. And the diagonals are perpendicular, and they bisect the angles of the rhombus. So all four of the angles in the rhombus are bisected by the two diagonals. In a square, the square has all the properties of a rhombus, a rectangle, and a parallelogram. I just put here specifically the isosceles trapezoid. It has one pair of parallel sides. They're called bases. The other sides are called legs, and they're congruent to each other. Hence the word isosceles, just like an isosceles triangle. The base angles, the ones on the same base, are congruent to each other. And angles that are on opposite bases are supplementary, meaning they add to 180. All four of the angles should add to 360. And the diagonals in an isosceles trapezoid are congruent to each other. So all these properties are helpful, usually in our case, in solving some sort of equation to find the length of a side, the measure of an angle, or the length of a diagonal. So it's good to have all these properties, and we can put them to good use when we practice together in class. And that's it.